So in this video, we'll go through the second part of the substitution. That is the second group of formulas for the substitution. And everyone, this is very important formulas, whatever we are going to do now. So now, these formulas are dx by x square plus a square, that is 1 by a tan inverse x by a, and integration dx by x square minus a square, that is 1 by 2a log of x minus a by x plus a. Number 3 this, and number 4 and 5 I have included here because one is root over x square plus a square, that is log of x plus root over x square plus a square, and one is root over x square minus a square, that is log of x minus. So here it is plus minus. According to plus the value is plus, and according to minus the value is minus. Okay, and last formula is dx by root over x square minus x square, the sin inverse x by. So one very important thing to know that how the formula is coming. Just I am showing you any one. Suppose first formula I am showing you how it is coming. That is very important. Suppose integration dx by x square plus a square. What will do? Let x equal to a tan theta. Let x equal to a tan theta. So dx equal to a sec square theta d theta. Now we'll put the value. Why I have taken a tan theta? Because 1 plus tan square is sec square theta. And everybody you have to know that how to substitute the trigonometric function, because calculus has that total deep relation with the trigonometry. Okay, तुम्हारा trigonometry जितना अच्छा से होगा, calculus उतना ही अच्छा से हो जाएगा. Therefore we can write here dx का जगह पे a sec square theta d theta, and in this case in the denominator x का जगह पे a tan theta. इसका मतलब a square into 1 plus tan square theta, that is sec square theta, that is a by a square is present here. So I can write here 1 by a square d theta. D theta का integration is theta plus c, that is 1 by a. In this case theta plus c, theta is tan inverse x by a. So one very important thing to notice. Is that in all these cases the numerical coefficient of x square is 1, unity. Okay, so everyone, this formula will work only when the numerical coefficient of x square should be 1. It can be numerical coefficient का क्या मतलब minus may be there, but the numerical coefficient of x square should be 1. Otherwise it will be difficult to use the formula. So let us proceed. Let's proceed, everyone. Suppose integration 2x square plus 5. First of all, the numerical coefficient of x square should be unity. Therefore, I can write here 1 by 2. So dx by x square plus 5 by 2. So constant can be manipulated in any way. So I can write here, if I give the root over 5 by 2 whole square, I can write here, this is coming to be half dx by x square plus root over of 5 by 2 whole square. So the formula is 1 by a tan inverse x by a, dx by x square plus a square, 1 by a tan inverse x by a. So constant we can manipulate in any way. So we can write here half 1 by a is मतलब root over of 5 by 2 wholes, root over of 5 by 2, and tan inverse x by root over of 5 by 2 plus c somewhere. Okay, in this way somewhere. I will go to the next. Suppose integration of 2x square minus 3. What to do for us? You see here, we have to match with this. Suppose this is x square minus a square, and whatever continuous I am telling you that numerical coefficient of x square should be unity. That is 1. So I can write here, if I take 2 common, so dx by x square minus 3 by 2. So our target is x square minus a square, so root over of 3 by 2. Root over of 3 by 2 whole square. Now 1 by 2a, 1 by 2a is root over of 3 by 2. So the reason is that this is a square. This is a square. So a is what? Root over of 3 by 2, 1 by 2a, and log of x minus root over of 3 by 2 by x plus root over of 3 by 2 plus c. Now we can calculate. We can simplify up your own. Okay. Next I am going to the next example. Suppose dx by x square minus 25. What to do with this? X square minus a square, 1 by 2 log of x minus a by x plus x. So I can write here, so what will write? So directly I am writing log of 1 by 2a, a is 5, log of x minus 5 by x plus 5 plus c. Done. I am going to the next. Dx by root over 3x square minus 1. Once again, the numerical coefficient of x square should be unity. Therefore, I can write here root over of 1/3 outside dx root over x square minus 1/3. So root over x square minus a square perform empiric. I can write here root 3 dx by root over x square minus 1 by root 3 whole square. So root over x square minus a square log of x plus root over x square minus a square, that form I can write here, that is log of x plus root over x square minus a square plus c. One more example I am showing you, that is integration dx by root over of 3 minus x square. So that the last formula, dx by root over x square minus x square. So that is the formula. The formula is telling that dx by root over x square minus x square, that is sine inverse x by a plus c. So I am writing here dx by root over of root 3 square minus x square, that is sine inverse x by root 3 plus c. Okay, suppose there is a sum. Suppose there is a question that x square dx by 9 minus x to the power 6. How to solve this sum? First of all, you have to remember one thing, everyone. Whatever there in the numerator, our target always you have to keep in mind this thing. Always to always write in this way. That we are always keep in mind in this way, that whatever there in the numerator, if it is anything, then we have to substitute. That should be 99% cases of the integration. You have to think like this. So x square, x square derivative x square. Obviously, you have to present x cube in the denominator. So what we'll do here, we can write x square dx, that is 9 minus x cube per whole square. So x cube equal to t. So 3x square dx equal to dt. I can write here, that is 1/3 x square dx removed in terms of 1/3 dt by 3 square minus t square. That is 1 by 2a log of a plus x by a minus x, therefore 3 plus t by 3 minus t. फाइनली हम लोग को t का वैल्यू पुट करना है.